so let's begin our talk on distance, rate, and time problems. Okay, so uniform motions. Go ahead and just write this on the top of your notes. We're going to be talking about 3 different types of problems. We're going to be talking about when you're going in opposite directions, the same direction, and round trip. Who can tell me which one of these, for sure, has the same distance? Connor. Why?
Because you went from one destination and coming back to another destination.
If you're going from one destination to another destination, then when you go there, when you come back, you drove the same distance, correct?
Mm-hmm.
Okay, so we would say round trip would be the same. Let me put that in red. Same. What about going in the same direction? If 2 people are going in the same direction, and then we stop them, would they be going the same amount of distance or different distance? It does kind of all depend, but in these problems that we're doing, they are going to be going the same distance. The only problems that you'll have to worry about at different distance is if 2 people or 2 things are going in opposite directions. But we're not going to even complicate it that much. We are going to make it nice and easy, and we just want to learn how to set these problems up, okay? So there's no reason to be scared. All right, so let's look at our first example. I'm going to write everything that I need in red and anything that I need to add in black.
Everything in red.
I'm going to write everything in red that they've given us because it's in red. Make sense? Okay, so example number 1. As you read, take notes. Leah left home. First of all, we're talking about Leah. She left home and drove toward the ferry office at an average speed of 22 kilometers per hour. So she's going in this direction, and she went 22 kilometers per hour. Where do you think I would put 22 kilometers per hour on this line right here? Under rate. Trevon left at the same time. Okay, so what am I going to do? Trevon left at the same time. Okay, I'm going to stop right there. They didn't tell me how much time, but they did tell me a piece of information that may or may not be useful to me. The same. I'm going to put that under notes. They left at the same time. So when Trevon left at the same time and drove in the opposite direction, so opposite means same distance or different distance? Different distance. So he went in the opposite direction with an average speed of 43 kilometers per hour. So where do you think I'm going to put 43? Underneath the rate. How long, okay, there's a key. When it asks you how long, that's a question right there. How long means what? Distance, time, or rate?
No, time.
How long, time. So where do you think I'm going to put my variable?
Total.
Under T for time. How long? How long who? Trevon. How long does Trevon need to drive before they are 65 kilometers apart? So under time, I'm looking for how long it took Trevon. Let's talk about this part. How long did it take him before they were 65 kilometers apart? We don't know how much either one of them drove, right? We know their speed. We don't know how much they drove, but we do know that if we add their distances together, how far did they drive?
So,
If this is the house, and Leah went this way, and Trevon went that way, and then we said, stop, then he went a certain amount of distance, and she went a certain amount of distance, but when you add them together, they're 65. Yes?
if they say constant speed and using 1 hour to get, if you get it 33, and she's saying 22, it takes an hour to change to 55 kilometers.
Connor, you're not allowed to be that smart. You're not supposed to get there yet, okay? Just hold on to that. So if you already know that, where should I put 65? In this chart right here. What does 65 stand for? The total what? Distance. So where would I put it?
Under the D.
Under the D, down in the total, right? Every single problem that you run into will have either an answer here with these 4 boxes filled in, or these 2 boxes will be filled in and these 4 boxes. Those are the only ones we're going to work with. So it's pretty easy. So if you have something like, well, we'll see that in a second. Okay. So the only thing I need to fill in right now to get this whole problem started, I'm only missing 1 box. What is that box? The top T. Did they hint on what that top T would be?
Yeah.
Where? Look in my notes section.
At the same time.
They left at the same time, right? So don't they have the same variable? Okay, so now we are ready. Once you've got these 4 boxes filled in and this box filled in, we are ready to have our equation, create our equation. So, see how I used the black for having to add something? Let me ask you something. We'll do that later. R times T equals distance, correct? So couldn't I say that 22 times T equals Leah's distance? Isn't that true? That's what it says, right? Or 8 times time equals distance, so 22T. And Trevon is 43 times T. And if I add them together, I will get 65. So let's do that. 22T plus 43T equals 65. What's 22T and 43T? 65T. What do I do from here?
Divide 65 to both sides.
Divide 65 to both sides. T equals 1 what? Hour. They both drove an hour. She drove at 22 kilometers per hour. He drove at 43 kilometers per hour. Obviously, he got further, right, because he was driving faster. But they both drove 1 hour. Yes. No, you have to do it like this.
Wait, how are you doing it?
No, we've only done 1 problem, right?
No, but I'm going to do it for
Connor, we've only done 1 problem. Okay? All right. Believe me. Maria left home and traveled toward the capital at an average speed. First of all, let's write Maria's name. Maria is going towards the capital at an average speed of 80 kilometers per hour, so she's going 80. Sometime later. Sometime later. What am I going to do with that?
Notes.
Note. His name's Imani. Imani left later. Sometime later, Imani, let's write his name here, left traveling in the opposite direction. Opposite direction means what? Different distance. Means we're going to have to total up their distance. Sometime later, Imani left traveling in the opposite direction with an average speed of 45. Put his speed right here. After Maria had traveled for 6 hours. Where are we going to put 6? Under time. Under who? Maria. After Maria had traveled for 6 hours, They were 705 kilometers apart. Where does 705 go?
The total distance.
In the total distance. Find the number of hours Imani traveled. So what am I looking for? How far Imani traveled. Find how far he traveled. No. Find the number of hours he traveled. Sorry. So that would be right there. We don't know how many hours he traveled. But what do we know?
That he left later.
That he left later. If he left later, did he drive more hours or did she drive more hours? She drove more hours. So the reason I have this over here is when you come back and you answer this, you should be able to go back and say, all right, I know that he should be, that if I get an answer that is less time, then I know that I'm right. Correct?
Yes.
All right, let's set it up. What goes here? Or 80 times 6, and here?
45T.
45T, and we're going to add those together, so let's write our equation. 80 times 6 is 480 plus 45T equals what? 705. Solve that one for me. Subtract 480 from both sides. What do you get? You guys have calculators. 45T equals what? $225. So how long? 5. Would that make sense? Can T equal 5?
Yeah.
So how long after she was driving did he start driving?
No.
An hour, right? But they didn't ask us that. I'm just asking you. They just want to know, find the number of hours that he traveled. He traveled for 5 hours. He traveled less than her, right?
Yes. It's enough later.
Because he left later. All right. A passenger train traveled to the repair yard and back. There and back. What kind of problem is this?
So it's a round trip.
Round trip. Round trip has what? Same distance or different distance?
Same.
Same distance. Right from the very beginning, no matter what problem it is in this class. Now, problems can get more complicated in word problems like this. But for our purposes, if it's round trip, you may put D and D because they are going the same distance. The train there goes a distance of D, and the train back goes a distance of D. Let's continue. A passenger train traveled to the repair yards and back. On the trip there, so there and back. So on the trip there, it traveled 68 miles an hour. There was 68. On the return trip, it went 85 miles an hour. How long did the trip there take? Where am I going to put an X? How long did the trip there take?
Oh,
T at there. That's what we're looking for. How long did the trip there take? If the return trip took 4 hours, where am I going to put 4? Under the return. Okay, so let me ask you something. This is a little side note. You don't need to write it. If I were to say 2 plus 4 equals 6, would you believe me? If I were to say 3 plus 3 equals 6, would you believe me?
Yes.
What if I were to say 2 plus 4 equals 3 plus 3?
Yes.
So if D equals D, these two equal each other? Don't these two equal each other?
No, because they don't want to get
But if their distances are the same, isn't their rate times time the same? Look at this up here. If 2 plus 4 is 6, right? I know that whatever this is, no matter what this is, the answer to it is D. And I know no matter what this is, the answer to it is D. Don't they have to be equal to each other? Correct? If I don't know how old your sister is, and I don't know how old your sister is, but I say that their sisters are the same age, don't they have to be?
Yes.
If I say that their sisters have to be the same age, no matter what their ages are, aren't they both the same age?
Oh, yeah.
Even though I don't know how old they are?
Because, what if and like, if one person is 6 and another person is 12,
But that's not what this is. That says D equals D. Their distances are the same. Let's continue the problem and see if it unravels for you. So if I say that D, their distances are the same, then whatever this is multiplied by is the same, then wouldn't it just be 68 times T equals 85 times 4? How do I solve that? Put in your calculator. What's 85 times 4? How much? 340? 68T equals 340. What's 340 divided by 68? So if going there, they drive 68 miles per hour for 5 hours. What's 68 miles per hour times 5 hours? What is that? 68 miles per hour times 5 hours. We just figured out T was 5, right? What is that?
340.
Oh. Did we find this right? This should be 68, not 65. 340 divided by 68, is it still 5? Okay. So we found out that the time it took to get there took 5 hours, right? First of all, does that make sense that it would take longer to get there? Why?
It's going at a slower rate.
Because it's going at a slower rate. But tell me, if you're driving at 68 miles for every hour you drive, how far did you drive for 5 hours? 68 times 5 is what? 340. And what's 85 times 4? So don't these equal each other, no matter what? They still equal each other.
Okay, I get it.
Do you see it?
Yeah.
No matter what the answer is, this has to equal this because rate times time equals distance.
I get it.
So if you go at a faster rate for a shorter period of time, you could have the same distance as going a shorter rate for a longer time. You're still going the same distance. Okay, let's continue. A submarine travels to St. Vincent and back. There and back. What is this? Round trip. Round trip means double D. It took 3 hours less time to get there than it did to get back. Those are notes. 3 hours less to get back. It took, let's read it again. It took 3 hours less time to get there than it did to get back. So 3 hours less to get there. So who's going to be bigger? Getting there or getting back?
Getting back.
3 hours less to get there. So getting back is going to be larger, right, than getting there. This is going to be a smaller number than this, correct? Does everybody see that?
Yes.
By that little piece of information they gave me, the time to get there is less than it is to get back. So let's continue. It took 3 hours less time to get there than to get back. So this is there. This is back. The average speed on the trip there was 30 kilometers per hour. The average speed on the way back was 20. How many hours did the trip there take? Where am I going to put my variable? But where? There or back? It says how many hours did the trip there take? So if the trip there took T and going back was more hours, what would I put here? This says 3 hours less, but look at my little marks here. This took less than this. The time here should be more than the time here. If that doesn't make sense to you, put real numbers in there. Just make it up. How long do you think it took them to get there? 4. 5? 4? Which one?
5.
4. It took 4 hours to get there. If it took 4 hours to get there, how long did it take to get back?
5.
Why 5? If it took 4 hours, it took 7 hours to get back because it took 3 hours more, right? What did you do to get from 4 hours to 7 hours? You added 3. So wouldn't I just do T plus 3? Are you writing anything down?
Yes.
Yes.
Okay, good. This is the hardest part. But my best advice to you is to write your little notes, make sense of them. If 3 hours less means less, and this means more, then put a real number in there and say, okay, let's pretend like took 10 hours. If it took 10 hours to get there, how long did it take to get back? 13 hours. 3 hours more. So if it takes more, then you know you got to add. Right? Okay. So we don't even have to pay attention to this, right? What's our equation? 30T. Hold on, let me change my pen. Because we had to add this. That was not in the original equation for the problem. Okay, so my equation is 30T equals 20 times T plus 3. We know how to solve that, right? What do I do? Distribute. So 30T equals 20T plus 60. If I take 20T off of both sides, what am I left with over here? 10T equals 60. So what's T equal? Does it make sense? If T equals 6, how long did it take to get back? 9. Are there difference of 3 hours between them? Yeah. Starting to get it a little bit? Let's do another one. The way to get these is repetition, doing them over and over and over, and pretty soon you're like, this isn't really that hard.
Wait, are the challenges?
No. Okay, Micaela, right, Micaela, let's call her Mick. Micaela left the hardware store and traveled towards her friend's house at an average speed of 25 kilometers per hour. Nicole left sometime later. Nicole left later. You guys understand why I'm putting it in her notes, right? It's not enough to put in my box, but it is of interest to me, correct? So Nicole left sometime later, traveling in the same direction. Same direction. Does that mean same distance or different distance?
No, same distance.
Same. Remember I told you all of these problems, it'll be the same distance. Look it, aren't they going to the same place?
Oh, yes.
Right? Okay, so Nicole left sometime later, traveling in the same direction at an average speed of 30. Why is she going 30? Because she's going faster because she left later, right? After traveling for 5 hours, she ran for 5 hours to catch up with Micaela. After traveling for 5 hours, Nicole caught up with Micaela. So where am I going to put 5 hours?
5 hours in.
Oh, here's Nicole.
Nicole's
Nicole's time, it took her 5 hours. After traveling for 5 hours, Nicole caught up with Micaela. It means Nicole ran for 5 hours. How long did Micaela travel before Nicole caught up? We don't know yet. What am I going to put here? That's what I'm looking for, right? Since it's the same distance, this is a D problem. Therefore, if D equals D, then 25T equals 30 times 5, right? 25T equals 150. T equals 6. Would that make sense?
Yes.
If Micaela was running for 6 hours and Nicole left after her, then Nicole is only running for 5 hours. Does that make sense? Let's look at this rate. Micaela was running at 25 kilometers per hour. I mean, she was going slower, right? Took her longer to get there. Make sense? A passenger plane left New York and flew east. Plane. A jet left 1 hour later. I don't know what to put in time yet. Didn't say he's traveling for an hour. It said he was traveling what?
An hour later.
An hour later. So the jet left 1 hour later. Let's apply some plus and minuses right here. If the jet left an hour later, who is traveling for a longer time? The plane is traveling for a longer time, right? The jet is traveling less time. Less by how much? By an hour. Right? If he left an hour later, then he's only going to be traveling for 1 hour less than the plane is. Let's continue. If they're going in the same direction, what do I put here? D and D. So a jet left 1 hour later, flying at 280 kilometers per hour. He was going 280 in an effort to catch up to the passenger plane. He's got to make up an hour, right? After flying for 7 hours, the jet finally caught up. How long did the jet fly? So if the jet flew 7 hours, how long did the plane fly?
8.
Look at this.
8.
See that? The plane flew 1 hour longer.
Don't know how fast it flew.
We just don't know how fast it flew. It says find the passenger plane's average speed. Let's find its speed if we knew it flew for an hour later. Because it's going slower, right? All right, so what's my equation? 8 times R equals 280 times 7. Tell me what it is. 1,960. So what's R? 245? Does that make sense? Going slower for a longer period of time? That's it. 245, what is it? Kilometers per hour? Kilometers per hour. Let's try and get one challenge in. Julio left school and drove toward the recycling plant at an average speed. Okay, we're getting too much. We need to start writing things down. First of all, we're talking about Julio. Correct? My pen is messing up. Sorry. Julio. Who else are we talking about in here? Aliyah. Julio left school and drove toward the recycler, so we're going to draw it. So here is, he left, and he's going towards the recycling plant at an average speed of 30. So I'm going to put 30 in here. Aliyah left 4 hours later. I don't know what to put in T, but I know that Aliyah left 4 hours later. If she leaves 4 hours later, and he's already been traveling for 4 hours, and I say stop, who was traveling longer?
Aliyah.
Julio.
Oh, Julio.
He was traveling longer, right? If I'm sitting in my house and Julio's already left, and then I decide to leave, and then we stop time, he's going to be traveling longer than I am, right? So, Aliyah left 4 hours later and drove in the opposite direction. Opposite direction means same distance or different distance?
Different.
Different distance. So we're going to have a total distance right here, right? Opposite direction with an average speed of 50. So he's going 50. She's going 30. No, she's going 50. He's going 30. He's going in that direction. She's going in this direction. Find the number of hours Aliyah needs to drive. So where am I going to put my variable? Find the number of hours Aliyah needs to drive. Time under Aliyah. Find the number of hours Aliyah needs to drive before they are both 280 kilometers apart. Where am I going to put 280?
Bottom USD.
Bottom total. The only box I need to fill in is that top right box. What could I put in there? Who drove longer?
Julio.
Julio. By how much?
4 hours.
So what would I write?
4 hours plus T.
T plus 4. Make sense? Julio drove longer by 4 hours. So whatever it was, we don't know how long Aliyah was driving, but she was driving for a certain amount of time. Add 4 to that, and that's how long Julio drove.
Is it double D?
Does it look like double D?
Yeah.
No.
No. There aren't any D's here, so what do I need to do?
Put them there.
What did I do last time? The very first 2 problems.
Oh, you just put the
30 times T plus 4 and 50 times T. And if I add those up, I should get 280. 30 times T plus 4 plus 50 T equals 280. So 30T plus 120 plus 50T equals 280. So 80T plus 120 equals 280. Take 120 off of both sides. What do you get?
No,
160. So how much is T worth? 2. Right? The zeros cancel. 2 what? What are we looking for?
2 hours.
2 hours. And 2 hours was what? Whose time?
For Aliyah.
Aliyah. If Aliyah was 2 hours, then how long did Julio drive? 6. Good job, guys. We'll stop there.